Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hello, welcome to Schweitzer Drive. I'm Dave Whitehead, and on this podcast, guests include power industry experts, which are often engineers with decades of experience under their belt. Today, we're taking a slightly different approach and chatting with folks just starting their engineering careers. In a study conducted by the Research Journal of Engineering Education, senior engineering majors were surveyed about their postgraduate intentions. Less than half of the students reported that they fully intended to pursue engineering careers. This, paired with the anticipated 400,000 new engineers needed in the U.S. each year, could be a cause of concern. That's why I'm excited to talk to Lyssa and Cameron Blegen. In May 2021, Lyssa graduated from Gonzaga University with a bachelor's degree in electrical engineering, and Cameron graduated from Montana State University with a bachelor's degree in computer engineering. That summer, they both started careers at SEL in the Engineering Rotation Program, an 18-month program that allows new engineers to work in a different division every 6 months. After finishing the program, they began their full-time SEL roles, Lyssa as a hardware engineer and Cameron as a software engineer, which they continue to work in today. Lyssa, Cameron, thanks for joining me.
Yeah, thanks for having us, Dave.
Yeah, thanks.
This is going to be fun. It's been about 35 years since I've graduated from college. So talking to people, let's say, new in the sport, it's going to be great to get your perspective on things nowadays. To start, will you tell me why you decided to study engineering and how you got started at SEL? Cameron, let's start with you.
Yeah, I think if I think back, the first kind of brush with thinking about engineering as a job was thinking about my dad and both my grandpas are civil engineers. So I got to hear a lot about roads and bridges, and every time we drove by a bridge, oh, look at that cool bridge. And as a kid, you kind of, okay, yeah, cool, dad, cool bridge. But as I got older, I started to realize how cool the system of kind of the road networks are. You get an Amazon package from one side of the country to another on a truck to my front door. It was pretty cool. So those complex systems were fascinating to me. I kind of started to figure out my own interests, looking into search algorithm stuff, kind of for SEO, trying to rank on Google kind of stuff. Started building
search engine optimization, SEO. That's
exactly
what you're talking about? Yeah.
Yep. Search engine optimization. I started building some FPV drones, which I heard in a previous podcast with one of the high school interns who interviewed Caden. He was doing similar, really cool stuff with that. So that was kind of cool to hear. And then I was kind of always our family's IT guy. So I was like, oh, he's the computer guy. So kind of taking this interest of complex systems with these things that I started to find my own passions in. Also, I had this really awesome AP computer science teacher in high school. And that was where I saw kind of computer science, computer engineering, what that would look like in a career context, in a kind of a real world context, not just a hobby of playing around with stuff. And so from there, looking at electrical computer engineering is when I decided to pursue computer engineering. So fast forward, getting ready to graduate, thinking about jobs. I had a family friend, Paul Robertson, who you've also had on the podcast. He had mentioned SEL. He'd given me the tour of the office and talked about what they do. And originally I'd kind of thought, SEL, it's pretty cool, but, there's all these things in the news of drones, and that's what I do. I want to do, drone startup stuff. But getting closer to graduation, I started realizing, this is really cool. This is the biggest system in the world is the electric power grid. And that kind of cool factor for me was there. And then I was still unsure where in engineering I wanted to land. So when I heard about the rotation program, it seemed like an awesome opportunity to kind of pursue that in an area that I thought was really cool.
Excellent. Lyssa?
I always loved math. Like, that was my favorite class in school. And in 5th or 6th grade, I was sitting in English class, absolutely struggling with the rules of grammar. And I gave a little lip to my teacher. And I was like, this sucks. And the teacher turned around, you hate writing, you love math, you should be an engineer. And at that moment, I was like, oh, why would I want to be an engineer? And he was like, they do math every day. And so that moment I was like, yes, I want to be an engineer. And so I started taking more classes. I started learning more about it. And I was like, I want to do math every day. It was a little heartbreaking learning later on that as an engineer, I would have to write as well, because every time you solve a problem, you have to write down how you solved it. But the math was enough that it got me over that. And so that really got me on the engineering path. And then how I got started at SEL was I actually grew up in the Moscow-Pullman area, and I already knew about SEL. I knew they were an electrical engineering company, and I saw a lot of value they were putting in the community. For example, like Camp Grizzly, they donated to it, and it was this Boy Scout camp that provided a lot of value to our community. And so the fact that they interacted and promoted community values was very exciting to me. My senior year, Paul Robertson, who connected Cameron, was my senior design advisor. And I mentioned I was interested in SEL, but I didn't know what to do. And he was like, you don't know what to do, but you want to work for SEL? I know this really cool program called the Engineering Rotation Program. I'm going to give your resume to the program manager, Jennifer White, and I'll have her reach out to you. And so that's how I got my foot in the door at SEL.
There seems to be in each of your stories this one pivotal moment, if you will, one person that tipped the scales. I'm not too dissimilar. I remember growing up, I wanted to be a lawyer. I loved arguing with people. You tell me which side you want to take, right? And I'll take the other one, and we can just argue about something. Until I had a physics teacher my senior year in high school, and it was the tipping point. That's when I decided I wanted to be an engineer. So I got to remember that, because we were talking about how do we get more students interested in becoming engineers. And it seems like this high school, there's always this tipping point, maybe even junior high or elementary school, where there's this tipping point. If you're waiting for them to figure it out when they're in college, it's probably too late. And let's follow a little bit on that. As you heard in the intro, a lot of students graduating with engineering degrees don't stay in the field long. From your perspective, why do you think that is?
I don't think people know what engineers do to the day-to-day. And this affects what people want to do. So I actually reached out to some of my classmates and talked to them about this topic. And one of my classmates, Alex, he described something called the cool factor. And so when he was younger and he was like, man, I want to be an engineer. I want to go design rockets or send things to space. That was his idea of engineering. And that's not necessarily everyday engineering. But what he's doing now, he's graduated, has an electrical engineering degree, is he's trying to determine how many outlets and lights are acceptable to be on certain breakers. And both are very important, but that doesn't match with his idea he had when he was a kid. So that disconnection, I think, is very important. Interesting.
Cameron, what do you think?
Yeah, so I know for me, when I kind of think about this question applied to myself, I like engineering. I plan to stay in engineering because when I go to work, I like what I do. I like the impact it can make. I like and it's not just about things I like, but I think overall my experience with engineering and SEL has been positive, not just in the sense that I enjoy, the benefits and I get to work with cool stuff, but this sense of fulfillment that you have as kind of a collective, the thing you're working towards. I just haven't had that in other jobs I've had, this kind of bigger purpose. And I think kind of on the flip side, I think people don't stay in the engineering field long because they never kind of get that feeling. So I feel fortunate that, especially through the rotation program, I've kind of got to experience that. But I think that would be one thing. I don't know anyone who has left the engineering field, but I know peers who are unhappy or maybe not living up to their full potential in engineering because they just haven't got to experience other parts of engineering that maybe would either broaden their perspective or fit a little better with their interests and their skills. I think another thing is engineering is different than school. So I think, you can go through a whole engineering program. You've got a degree that says, engineering in the name, and you go work and it's not just this math problem to solve or this, project with really well-defined parameters. You're kind of now in the open world of solving problems with engineering tools, but problems that have never been solved before. And I thought that was really exciting. I liked that shift from school, but I have some friends I know who didn't like that kind of open-endedness, that shift.
Maybe one of the challenges that young engineers in their career might be thinking about well, leaving the engineering field is that a lot of us don't know exactly what it is we want to do, say when we going into college or more maybe importantly, graduating. Used to be when I started at SEL, you had to have 5 years of experience in something. So by that time, when you came to SEL, it's like I already knew what I wanted to do because I've been doing it for essentially 5 years. I was a hardware engineer when I came here. And when I was talking to some of our HR people about the engineering rotation program, a lot of folks don't know exactly what kind of engineer they want to be. Do I want to work in a manufacturing environment? Do I want to work in the R&D environment? Do I want to help customers apply our products in some technical fashion? And that was kind of the genesis, if you will, about the engineering rotation. But give new folks right out of school an opportunity to try out different parts of the company before they really, roll up their sleeves and start digging into what it is they're going to be doing for the next 2, 3, 4 years or whatever it might be. Cameron, what 3 rotations did you do in the program?
Yeah, so my first rotation was R&D, infrastructure application development. So it was a full stack development team that worked on internal tools. So the tool I was specifically working on was for the PCB designers. It maintained a lot of their data. Parts of it were plugging into some information the new PCB factory was consuming for their board stack-ups and layers and all that data. So that was pretty cool. Kind of first taste into the full stack world for me. I went then to manufacturing in at the time test innovation group. They're kind of responsible for bringing in the kind of next generation cutting edge, bleeding edge test technology. So I got to work a lot on the flying probe as they were kind of coming up. Flying probe tester is this kind of state of the art tester with a bunch of probes that fly around and poke different parts of the board to test it. As opposed to our current ones, which they just are pins that don't move. So that was really cool. And then I went back to R&D. That's not always typical in the rotation program. Usually you do a third different department, but I was really interested more in the R&D side. So I got to go back. It was more of a slightly more customer-oriented role. So I was doing support for RTAC from an R&D position. So, if it made it through the first line of defense, it would come to the RTAC libraries team is who I was on. And we'd help people get to the bottom of their problems, usually internal customers, but external too.
Excellent. Lyssa, how about you?
For me, something that's really helped me stay in engineering is I think I have the coolest job in the world. Or something like how I referred to the cool factor earlier. I work with the electromagnetic fields, and I often have other engineers come to me and say, it's like magic what you do. And that always sparks like the quote in my head, the magic is just science we don't understand yet, the Arthur Clarke quote. And I love that because I'm in a position where I'm given a problem and I start with research. I'm pulling up white papers and grabbing textbooks, trying to figure out how are we going to address this problem. And then I sit down and I do the math that I loved when I was in elementary school, not the same math, but just math in general. And then I go to simulation and try running it in simulation. And then I actually just go down to the lab and try it. So I'm literally taking what some people consider magic and turning it into science to fix a problem. And so because it's the coolest thing ever, I feel like I can just do it every day.
Now, are you good at picking which coordinate system to use to solve, say, a fields and waves problem?
I think it all depends on the shape that we're dealing with.
Well, I can remember doing all my classwork, and I would invariably pick whether it was supposed to be rectangular, I'd pick polar, and it would take me 12 pages to solve versus the 1 page. So you probably are much better at that. But another question I was interested in, what 3 rotations did you go through?
So I started in R&D as a hardware engineer, and I kind of worked with 2 different teams at that time, both in our distribution team, our recloser control hardware team, and the electrodynamics team, which I am on now. Then I went to manufacturing as a test engineer, specifically for the radio products. And then I went to sales and customer service as an automation application engineer.
Oh, very good. Wow, you were all over the company too.
Yeah.
What have you experienced in your career so far that encouraged you to stay in the engineering field for, well, as long as you've been out of school now? Cameron, you want to take a swing at that one?
I think a lot of what I experienced that's encouraged me to stay in engineering so far has been kind of through the rotation program. A few pieces of that. I think a big one for me, I kind of already mentioned, I guess, I really like what I do. I don't think there's a dream job, but getting to try different rotations to find which one I just clicked with. And I didn't even end up in one of the 3 rotations, but it helped me kind of understand where in engineering I wanted to be. I ended up on a firmware team. So that was a big part of it. I think another great part of the rotation program was the intentional mentorship. So each rotation, you get a mentor, and it's more than just a boss. It's someone who's there. They know you're there for only 6 months per rotation. So they're going to do all they can to help you learn as much as possible. And so it really showed me that kind of compared to school where you're a lot on your own doing assignments, engineering in the real world is a team sport. So there's people who are going to, help you out. You're stuck on a problem. I didn't really expect that. I was a little nervous about that, starting a full-time career in engineering. Like, I gotta know all the things. But the mentorship was awesome to kind of get me over that hump. A lot of personal and professional growth through the rotation program. I think widening the perspective of, our manufacturing, our customers, our R&D, the whole process. Had I not seen the whole process start to finish, I think my little view of, just one team writing code, it would have been fine, but I don't think I would have kind of brought the passion that comes with understanding where you fit in the bigger picture. I think those are the main reasons I want to stay.
So what do you think?
I don't think I knew what I wanted to do out of school. I just had this degree and I could have gone anyway. And so if you had asked me before I graduated college if I was going to be a hardware engineer, I probably would have told you no. And so the fact that I got to try and actually experience it, knowing the difference between what the class teaches you, the tools that it teaches you, and actually applying them at work is such a big difference. And so the rotation program really helped cement what I was interested in, even though I didn't know that in school.
A couple other things we were hoping folks get out of the rotation program. First one is I'll call it a bilateral job interview, right? 3 of them you get to go through once every 6 months. One is you get to figure out if you like this part of the business at SEL. And on the second one, and you probably saw this too, is your supervisor, your mentor is doing 6 months to recruit you so that when you're done with the rotation program, you'll come back and work in their organization. The second part that I'm sure that's happened to you all. The second part, though, is what we want to make sure is you get some foundation that, as you pointed out, you're not just stuck in one part of the organization and your work product then is thrown over the wall to who knows who, right? But it goes through. It's rather you get a sense of if I'm in R&D, then it goes into manufacturing. This is how we test it, say with the Flying Pro machine, or it gets out into the field. And now a customer, one of our AEs, has a question about how does this thing work, right? And so you get to see that at least an attempt going through at least 3 rotations, really a large part of our company to get a sense for what's going on. I don't know if that was your experience or not, or your takeaway from it.
Yeah, absolutely. And I think going back to something we talked about a little earlier too, I think getting to try those 3, like you said, it felt like 3 kind of bilateral job interviews where, I get to try this out, and nowhere else do you get to do that. I think that's why you see the rising statistics of people, changing companies, changing jobs. Is there's this kind of want of new graduates to what's out there, what else is out there, not just satisfied with their kind of landing the first place they got an interview. And so it definitely provides that.
I was also thinking, you just sparked a story in my head where when I was in my first rotation in R&D, we had a problem where we were running out of space on a PCB, a printed circuit board. And we had this circuit. We were like, if we could just pull the circuit off and put it on a different board, just a brand new board, it would just save us everything. It fixes every problem. And we took it to the team. We were like, hey, and it was a mix of like R&D and manufacturing. And then the project lead would have to make a decision if that was acceptable. And we were like, hey, this solves our entire problem. Let's do this. It's perfect. And we got told no. And we were like, what? That doesn't make sense. We have a brilliant solution. But then when I went to work in manufacturing, I could see the additional work, the potential problems that creating another board could have. It was going to lead to having to store that additional printed circuit board, having to create tests, fixtures to test it. And then once we built it, we would have to store it for when it's needed. And so it really gave me an opportunity to look and go, oh, solution in R&D might not be a solution in another division that might cause problems for them. And that wasn't something I really understood until I rotated through the different divisions.
Did you guys take any control system classes?
Yes.
Okay. So in control system, right, there's always this optimization problem that you're working on, right? And one of the things we look at is these local minimas and global minimas, right? And you're always trying to go down this, basically this gradient, if you will. And it's is going to sound weird on this podcast, but this gradient is like this multidimensional gradient, and you want to minimize the error as much as you can. And you can hit these local minimas where you get to a sweet spot, but if you just had a little bit more perturbation in the system, you get to an even better optimization problem. We often do that in engineering and other parts of the companies where I've optimized my part of the problem at the detriment to the rest of the organization. So that's a great story. And again, maybe to follow on, that's one of the great outcomes we were hoping for the ERP program, that you get to see a bigger picture, not just your small part in R&D or manufacturing or in our customer service division. So let's pull on that thread again. Had you not gone through the engineering rotation program, how do you think your careers might have been impacted, or what might have been different?
Yeah, I think the first thing that comes to mind is the network, and it could sound very businessy, but really just the personal relationships more so of, I now have a person I know in R&D infrastructure, and I can ask them a question. I can ask somebody a question in manufacturing, or they can come to me and say, hey, you're on this firmware team now. Why is this way the thing it is? And I think for me individually, that's been really useful for my work, but I think kind of as a company as a whole, sending out more and more ERPs kind of into the, I guess, full-time positions. I think all of us would say a similar thing. Both the network we have within the ERP, there's almost 50 other people that we know who have been through the same 6-month rotations who have that kind of expanded network. It really makes, as SEL grows, it really makes it feel small again, which I've appreciated. And it's a lot more fun too. Instead of, sitting with a problem and scratching your head, it's like, oh, let me call so-and-so up and I bet they'll have an answer or they'll know who. And that was a really cool part for me.
That's cool.
Yeah.
I really agree on that with the network. That's been so helpful in my career.
Are you still in touch with your cohort, your ERP cohort?
Yeah, I actually have a chat that we have, and we'll throw messages in like, oh, I've just done this, or we'll see a picture of one of us and we'll be like, hey, I saw this picture at this conference. I didn't know you went to this conference. And so it's a fun little way we use to keep in contact, even though we're in different divisions now. So like I'm in R&D, and then one of us is in sales and customer service, another's in ES, and then another is in infrastructure defense. So
wow, that is really, really a cool story. Lyssa, I've heard you had an opportunity to work on research that led to a patent application during the ERP. Will you tell us more about that? And have you applied for any more since then?
I can address that second question really quickly. Yes, I actually have. But going back to the first one, in my first rotation, I was introduced to this problem where for our sensors, we primarily just measure current. And someone was like, what if we could measure voltage and current? And I was like, oh, that's a cool problem. They were like, I'm glad you think so because you're going to be working on it. And I was like, oh, okay. And so they kind of had this idea, like, could we use the electric field and the magnetic field in one component to then be able to measure the voltage as well as current? And so
you're using the electrostatic field to measure
we're almost creating a capacitor between the windings. So we step down the current, and then we in that space where we step down, we're trying to create a capacitor so we can then create a difference in potential.
Mm-hmm.
And so I got introduced to it, and then I was told start simulating. So I ran LT SPICE simulations for possible circuits, and then I also did ANSYS simulations to work with the field side of it to see if we can create the field necessary to do this. And then probably like 3 weeks left in the rotation, they were like, I think your simulation is enough proof of concept. Now trying to build a mock-up, try and see if we can actually build something. And so then I spent the last 3 weeks trying to build it in-house. And then at the end, the lead engineer on this, Dr. Tim Mintier, he was like, hey, by the way, this is a patentable idea. It's a patent. I filled out the application and your name's on it.
Oh, that's awesome. What product were you working on? Was it an overhead sensor? Or
it was for an overhead sensor. This patent hasn't been put to a specific product yet, but it was for research at the time.
So if it's the problem or product that I think you're trying to solve, one is we hang sensors on wires, and it's pretty easy to measure the current, right?
Yeah.
Through induction. The hard thing is to measure voltage. And what we were trying to do is was the fault in front of me or is the fault behind me? And you need some sort of reference, and we usually use voltage as our reference. But when you hang something on a wire, measuring voltage, I like to say is you like to push against something, right? You have ground as your reference, and then it's really, really easy to measure voltage. But when you hang something on a wire, it just kind of dangles there, and there's nothing to push against. So you actually have to get back to Maxwell's equations, right? And think about the electrostatic field between a plate that's an inch from the wire and one that's, say, 4 inches from the wire. And I think that's the problem you were working on, wasn't it?
Trying to find ground is a big part of this problem, or just a reference point to use as our ground.
That something. What are you going to push against, right?
And so one thing is like, well, what if it connects to the pole and all 3 lines at the same time?
That's cheating. That's the easy way to do it.
Maybe, but still a cool idea to try and get that
it really
voltage.
is. The problem is it's now you got some high voltage you want to connect to
and you
ground.
need the isolation.
Yeah, exactly, and a safety thing, right? So that can become that data. But working on a patent, is in your ERP, that is really, really cool. We like to pride ourselves on being a company of innovators, right? And so you're starting off on a good foot.
I think it was interesting that I didn't really know it was a patent because I'd never worked on a patent before, a patentable idea before. To me, someone had just given me a problem and told me to go solve it. And that kind of felt like school. Someone handed me a problem and said, solve it, come back at this time. And so to me, I was like, okay, I can solve this. I can do this. But then in the end, it was like, oh, but this is a novel idea. So let's patent this.
Well, and that's, I've heard that quite a few times, right? Once you've solved it, it's obvious to you. Right. But up until that point, nobody had solved the problem. So that's the ingenious part of it. Aside from the programs like ERP, is there anything you think employers could be doing to retain engineering employees or to get them excited about engineering in the first place? Let's start with you.
This building communities, I think, is a big part of trying to keep employees. So we have the engineering rotation program, Cameron and I, and that was a big thing about creating a network of young engineers and putting us through kind of similar experiences and having people to talk to. But SEL also has a couple of other programs that do the same thing, this building community and networks, like our engineering development program, which is for young engineers as well, to kind of connect them, but also trying to give them help teach the tools necessary to grow them as engineers. We also have the Women in STEM program. And so in engineering, it's a male-dominated field, so it's kind of cool to have these programs in SEL that helps connect different women in different areas to each other to help build that camaraderie.
Yeah, WeSTEM is a huge organization within SEL. I don't know how many members there are now, probably close to 500, I think. It's an amazing organization. It's all self-driven. This is not some manager in some organization that's doing this. Is all grassroots and the members manage it. It's quite impressive. And
it's pretty cool. The other girl in my cohort, she is actually on the board for the Women in STEM group right now. So
wow. Cameron, what do you think?
Yeah, I mean, I think the ERP is a really good example, and it sounds like, we kind of gush about the ERP, but it really was formative in my career. I think if an employer's, thinking about what they could do, if they couldn't spin up a whole, ERP type program, there's a lot of things you can, I think, take from it. Like Lyssa said, the community was huge. Having other people who are just starting your career, who are going through the same thing, that was awesome. And we still talk to those people, shoot them messages, hang out and stuff like that. That was really cool. The culture part of that we got to understand through the ERP, I've heard you say on the podcast before, culture eats strategy for breakfast. And I think that SEL does a really good job with their culture, but you really get to feel it when you get to rotate through different groups. So that's a hard one for an employer to just, make good culture. But I think that's, little things over time, like SEL's done for years, I think was a huge part of why, I chose to stay in engineering and chose to stay here. I think another thing too is breaking down some stereotypes in engineering. We need the people who are going to sit and just work on math problems all day. Like that is a lot of engineering for sure. But I think there's space in engineering for people who just want to be problem solvers. Mm-hmm. And that was kind of a cool thing to see rotating through some groups that I hadn't, really had much experience in. Is it's not as important that you have the specific skills, but that you kind of bring this mindset. So yeah, I think as far as attracting new people to engineering, that would be what I would say.
What advice would you give to, somebody just thinking about engineering or maybe considering going in the field or maybe even just starting out?
Yeah, I think a couple of things come to mind. My experience, kind of just starting, thinking back on it, it's been 3 years ago now. It feels like, just a few months ago. I remember this feeling of, oh my gosh, fire hose of information. There's so much to learn. How can I ever, learn all that I need to know to do anything? But then, you kind of have this, you work hard, you're trying to figure it out, and you have this aha moment. And I mean, it could be small. I had this in each rotation, just a little thing like, oh, I made that button work, or, oh, the flying probe machine turned on, like something silly. But I would say if you're just starting out in your career and it feels like that, like stick with it until one of those moments. Cause that was when I realized like, oh, one of those moments was all it kind of took to spark the next moment, and enough of those little moments together. And all of a sudden, I'm contributing. People are starting to ask me questions, and it is a really good feeling. And I think, if you quit too early, it's going to feel impossible. And then kind of similar, I guess, is Jennifer White, your program manager, ERP, that Lyssa mentioned, she always says, your number one job in the program is to learn. And she's always encouraging us, reach out to people, put yourself out there. I'd say if you're just starting your career, don't just sit at your desk and do what you're, assigned and go home and, try to think about what all the things you need to do. Ask people questions, take people to lunch, ask for tours, really putting yourself out there in each of the rotations, I think was really maximized my experience, and it all sticks with me, today in my current role.
Wow. Lyssa.
I kind of, to Cameron's first point, it's okay not to know something, but because you can go out and learn how to do it, or you can be taught. Like, for example, I'm a hardware engineer. I should be able to read any schematic, but the second day in my first rotation, they handed me a schematic and they said, figure out this circuit, what it's doing, because you need to learn about it because you'll be using it later on. And I looked at it and I was like, I don't know what's happening. I just went to school for 4 years and I'm staring at this piece of paper like, I think I know what's happening, but
what
that's
was it? What was the circuit?
It was a circuit that had a GNSS connection because it's for our clocks. Mm-hmm. And I just didn't understand ICs in schematics because they have consorts, which is where you pull like the supply voltage into the chip and the ground away. And so I was like, why are these sections of circuits just floating here by themselves? Or the same node on the same page is represented by a diamond. And so I didn't understand that some of these circuits were connecting. I was like, in school, everything was connected and I drew it out and we didn't have things that looked like ICs. It was still just the component. And so I was like so lost. And I was like, I don't understand. That was a really hard moment to get through because I went through school. I put in my 4 years. I feel like I did my time to get to that point. I applied. I made it through the interview process. I should be able to read a schematic. But I went and I had to ask for help. And they were like, oh, I just read them every day. I totally forgot that you might not understand how to read a schematic. So they sat down and broke it apart for me. And I was like, oh, and so now I read schematics every day trying to be like, oh, what is this component? Where is it? What's it doing? But I just remember that moment like, I don't know.
And it's okay to ask, right?
Yes.
That's the important thing to remember. Well, thank you both for spending some time. I'm walking out of this podcast encouraged for the future, certainly of SEL and probably for our electric industry or the electronics industry or engineering in general. And anybody else listening to the podcast, I'd really encourage if your company doesn't have an ERP program, maybe to consider it. I think there's a lot of benefit, not only for broadening the horizons of the folks in the ERP program, but on the other side is the people in the organization get to meet these new engineers or these technologists. With that, Cameron, Lyssa, thank you very much for your time. It was a great conversation. I'm gonna get back to you in 5 years and see where your careers are at.
Look forward to it.
Thanks.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.